Hello. How are you guys doing? Hopefully you guys are all well. Hopefully you guys had a good 4th of July. We had a pretty cool one out here. It's been interesting though because we had some earthquakes the last couple days. We haven't really had a big earthquake here in Southern California in a while. It's been quite a few years since we've had a large one, and I guess we were lucky. I mean, I don't want to take away from the trauma and whatever that people went through in the area of Ridgecrest and Trona, because that's where the earthquake was centered. It's about 100 and some change miles away from my house. So we felt the shaking at my house, but it wasn't even enough to have something fall off a shelf or anything like that. It was real mellow for us. So we actually had two rather large ones. I think we had like a 6.4 and then like a 6.8 or a 7.1 or something like that. But again, they were centered out in the middle of the Mojave Desert. So luckily, again, not taken away from the people that dealt with it there, but luckily it wasn't in an urban city where we had problems. So it's definitely a interesting 4th of July, I guess I could say. I didn't even feel the earthquake, to be honest with you. My wife and I were on a bike ride, and someone called me. We had left my kids at home because they didn't want to go for the bike ride with us because we went like too far, or it was too long of a ride and they didn't want to do it. But someone called me and said, "Hey, are you guys okay?" And I'm like, "What are you talking about?" And they explained to me, and I go, "I better call my kids." And I called my kids, and they were fine. So it was kind of cool because it was that. For those of you that don't deal with earthquakes very much, growing up, it was always something that was stressed to us, and we had to learn what to do if there was an earthquake, how to shut off the gas, different things like that in case something was damaged. And my kids, have never really been through, even this one for us wasn't that big. So we've never really been through that big of an earthquake. So it was kind of a great time for me to sit down with my kids and explain like the emergency plan and what to do and what not to do, and how not to worry about the animals if you have to leave the house, and just that kind of stuff. So anyways, I digress. We're going off on a tangent there about earthquakes. So, but hopefully you guys had a great Independence Day for you in the States, for those of you in the States. So I have some interesting stuff I want to talk about, and then I want to definitely get to your guys' questions in the chat. I mentioned already in the chat in the very beginning of this, for the guys that were in there really early, throw your questions in caps lock so myself and our moderator, Justin, can make sure that I get to the questions. And don't hesitate to repost your question if I don't answer it. You're not going to offend me by reposting it. Sometimes they just go so fast that I can't get to them. And then sometimes, too, I got a sheet right here of things I want to talk about. So sometimes I might be going off on a tangent and not see your question fly by. So you're not going to hurt my feelings if you post it again. So, all right. I want to start by addressing my videos, my two videos that I posted this last week. So I posted one on a Linux package unit where one of the compressors was disconnected. And I got a couple questions on there, and I kind of want to address them too. Remember that, people in the comments, they posted like, "Hey, I could hear that compressor was running backwards from the beginning." And yes, I realized that compressor was running backwards too, but I let it go so that way we can show the whole process of figuring it out, putting my gauges on it, seeing that we had no compression, reversing the phases, and then realizing that we had compression. I wanted to show that in the video, okay? So it's not that I'm missing that stuff, but I'm not saying that I don't. Sometimes I do. It is what it is. Never figured out why that compressor was unhooked. For those of you that don't know what I'm talking about, I uploaded a video where the second stage compressor, I believe, maybe it was the first stage, I can't remember. Yeah, I think it was the first stage. The first stage compressor was disconnected, but there was no notes or anything as to why it was disconnected. So I went through the process of making sure that it wasn't grounded and checking all that good stuff. Now, someone asked me a really good question, and it kind of segues into a topic that I want to cover, and it's how come I didn't use a mega ohm meter on that compressor to see if we had any insulation failure on the wiring or anything like that. And I'll be honest with you, I don't own a mega ohm meter. Nothing against them, okay? But I do want to say that you need to be very careful, and I think I covered this on my last stream, but I'm going to recover it again, that you do want to be very careful when you're using a mega ohm meter. Copeland actually has a tech bulletin. It's tech bulletin. I have it written right here on my notes. Tech bulletin AE4-1294. And I'll put a link into the chat right now. I'll put a link in the video show notes too. I don't know why I'm going to put it in the chat, but whatever. You guys can click on it or you guys can copy it or whatever. The This is Copeland's tech bulletin right here, but I will put a link in the show notes of this video too. And in the tech bulletin, Copeland acknowledges that a mega ohm meter is great for testing insulation value of wiring and different things, but they do express in this tech document, basically, or tech bulletin, that you need to be careful about using a mega ohm meter, and that they recommend that mega ohm meters are used over a length of time, and you should look at trending data before you just diagnose a bad compressor because a mega ohm reader has, a bad reading, basically. And the reason why is because there could be moisture in the system. If there's moisture in the system, it can lead to a false reading, basically. So you got to be very, very careful about that, okay? All you need to do is just Google search Copeland mega ohm meter, and you'll find the tech bulletin. It'll come right up on the Google search results. But you can also go to Copeland has a mobile app that you guys can download for your phone. It's called Tech Bulletins. If you just Google search, or not Google search, go into your app store, whether it be Apple or Android, and just type Copeland. And there's going to be all kinds of great apps, and you can find all kinds of cool stuff. So you can find just one app that specifically has tech bulletins, and you could just look up tech bulletins all the time. So if you want to know if there's like a known problem, just look it up and it explains it. So, William Powers, you said, what is the approach method? And that's actually something that I want to cover on here. So the approach method is Linux and some chiller manufacturers. I don't do any chiller work, but I have heard that some chiller manufacturers use the approach method too for a charging metric. But Linux has used this as their charging metric for many years on their commercial package units. And I don't do any of the residential stuff, but I'm pretty sure they use it for the residential stuff too. You guys in the chat can confirm whether or not you've seen that. But the approach method essentially is the difference between the liquid line temperature, so that's the surface temperature of the liquid line leaving the condenser, and the ambient air going into the condenser. So it's kind of an ass backwards subcooling measurement, right? Except for you're not doing the liquid saturation conversion temperature, okay? So you just take the liquid line temperature leaving the condenser, and you take the air temperature going into the condenser, and it's the difference between the two, and that is called the approach method, okay? And Linux has used that for many years as their charging metric. So you want to be very careful if you're charging a Linux unit. You don't necessarily, I'm not saying it's not going to work, but you don't necessarily want to charge by subcooling on a TXV system because you could overcharge it. So you want to be cautious about that. And also another thing too, especially when you're dealing with the Linux package units, is that have the slab condenser coils, the V-shaped coils. Usually those are circuits. So you might actually have a different air temperature, ambient air temperature on the back side of the condenser coil than you do on the front side of the condenser coil. So, if I'm thinking of a 15-ton package unit, the front of the condenser coil is the first and the third stage condenser on the front. On the 15 tons that have 3 compressors, the third stage shares half of the back slab, half of the front slab, and then the first stage is the top half of the front slab. So the front slab, so the first and the third stage might be getting 102 degree ambient air going into the condenser, when the back side might be getting 100 or 98 degrees, depending on it being in the shade or something. So you want to be cautious about when you're getting your air temperatures using the approach method. You want to make sure you're getting the proper ambient air temperature. So, all right. So this is actually a perfect segue to, let me pull up this tech bulletin right here. And actually, I'm going to segue to one of the other Copeland apps right now. I'm going to show you guys real quick, and then I'll get to some more topics. So I'm going to change my display right now. So it's going to pop up. Hang on just a second. And okay, so I'm going to segue over to a screen. I'm going to share my screen with you guys, and I'm going to show you the Copeland Mobile App. I had a lot of people asking about the Copeland Mobile App, and guys, I see your questions coming through. I'll get to them here in a few minutes, okay? I'm going to cover this topic first. So the Copeland Mobile App is something that I use to find out the resistance value of a compressor before. I actually used it just today because we had a Hoshizaki ice machine that had bad starting components. The potential relay had shorted out. And before I drove to go get the starting components, I wanted to ohm out the compressor to see if it had the right resistance values. So I opened up the Copeland Mobile App and I inputted the model number of the compressor, and I got my resistance values. So I'm going to pull up the Copeland Mobile App for you guys right now. I'm going to transition over. All right, so this is, for whatever reason, Copeland lets you use the mobile app on a computer too. So What I'm going to do is I'm going to input the model number. So I'm just going to input a CR18, and you notice that it auto-populates a lot of model numbers. So you need to make sure you find the right one. So we're just going to pick this one, CR18K6, Tom, Frank, David. And what you get to do is immediately it pops up and it asks you, which compressor do you have? Is it 463 phase or 423 phase? One of them's 50 hertz, one of them's 60 hertz. So here in the US, we'd be dealing with the 50 hertz model. So I'm going to click on that. And you notice that it gives you some information. Again, guys, for those of you just tuning in, I'm just kind of touring the Copeland Mobile App, okay? It's a great resource, and I highly suggest you guys download it. You can download it on iOS and or Android. Just go into the App Store and look up Copeland, and there'll be all kinds of apps, but this is Copeland Mobile. So the really cool thing about this app, and guys, I can't see the chat right now, so just bear with me. The really cool thing about this app is it has tons of information in here. So what we've got right now is, hang on. Okay, so we can look up mechanical information about the compressor. It tells you information about the mounting bolts, the suction line size, all that good stuff. But what I really like is the electrical. Okay, you go down to the electrical and look at the winding resistance down at the bottom. And it tells you that the winding resistance on this compressor, plus or minus 7%, should be 7.437. So this is a 3-phase, so it's line to line. So if it was a single phase, it would give you the start and the run winding. Some other cool things that if you guys don't already know about this app is that if this unit had capacitors, you can look up the capacitors and it gives you the part numbers and the data about the capacitors. You could do the same thing with a relay, potential or thermal, whatever. But this is a 3-phase compressor. So you can also look up service parts. And I really like this part because let's say this unit has a discharge line thermostat. You can click right here and it'll pop up. If it has some special gasket, if it's a semi-hermetic, it'll pop up. If it has a molded plug, this one has a power cable molded plug. There's the part number. Sight glasses. I mean, you could do all kinds of great information. Crankcase heaters. There it is right there. You know, there's all kinds of other great information. Fittings. So I highly suggest, if you guys haven't already, download the Copeland Mobile App. It's a great, great resource. You can also find, let's see right here, performance. They have a performance calculator, and they'll tell you can actually input your numbers. You can click on dynamic performance, and you can input your numbers, and it'll calculate how your compressor is operating and, you know, information about that. So it's a great, great app. I highly suggest you guys consider downloading this. I'm going to go ahead and switch from the screen share right now. And let's go ahead and go back to my video capture device. And there we go. So I'm back. I'm going to try to pull up the chat here, and I'll try to get to some of your guys' questions now. So let's go over here. Bear with me one sec. I just need to find where my chat disappeared on my screens here. There it is right there. All right. Okay, guys. So let me try to get to some of these questions. Okay. Yeah, the Copeland Mobile App is great. So I saw some questions come through. So Israel Miller, you asked if a compressor is sweating, is that a good indicator it's overcharged? And no, that is not a good indicator that it's overcharged. All that means is that the suction line temperature is below the dew point. That's all that means. It does not mean anything, okay? So the proper way, depending on what you're working on, if you're working on a fixed orifice device, is to use target superheat to find out if you're overcharged. And then if you're working on an expansion valve system, you're going to use subcooling to find out if it's overcharged. I guess I should say if that's an air conditioning system. If it was a refrigeration system, then you'd have to look at some other things. You'd clear the sight glass, make sure that you're not past the sight glass. But you know, you can also check the evaporator superheat. There's a lot of different things that you would have to check on a system to make sure. But as far as sweating back or even frosting back is not bad, so long as you have proper airflow and you have the proper superheat. It doesn't necessarily mean anything bad if your suction line is sweating back to your compressor. So, okay, guys, for those of you that have had Hoshizaki has a high and low port. What's the port in the middle that's not labeled? Human Rights Revolution. That's a good question. So I'm assuming that's a remote ice machine, meaning that it has a condenser on the roof. Most ice machines that are remote, they usually have a third port, or they tell you to use a 3-point recovery on that system. Because of check valves and solenoid valves that are in that system, they give you 3 points to access the system in case you have to recover the refrigerant. So typically on the Hoshizakis, You have a liquid port, you have a high side port, and you have a suction port. And you can use that third port essentially for your 3-point recovery if you needed to do so. So if you turned off the machine on a Hoshizaki and you went to go recover that gas, there's a potential that because of some check valves, you could still have refrigerant trapped in the system, even though your recovery machine goes into, or your suction line goes into a negative, and even your high side goes into a negative. It's possible you could have refrigerant trapped somewhere depending on where you put your high side port on. So they always give you that third port so that way you can access the system. If it doesn't have the third port, then on the Hoshizaki machines, usually on the line set on the back of the machine, they have ports usually on the line sets, and there's a discharge and a liquid line on the back of the machine going up to the condenser. And if you didn't have that third port, you can always access the discharge line on that on the back of the machine if you needed to. So hopefully that answers your question. And the same thing kind of goes for Manitowoc too. Manitowoc on their remote quiet cube machines, they give you 3 ports, and it's pretty much the same thing. It's just so you can access that third part of the system. So, okay. Let's see what else we got. Yeah, guys, if you guys got questions, type them in caps lock because it really, really helps us because there's so much. Sometimes we don't know if there's conversations going on or what in here. So, all right, let's see what else we got going on. Setting the record straight. Yeah, and I guess that's a good point. Zach, thank you so very much, man. I really appreciate it. Adam, you put in here that the entire compressor sweating as a whole, that should not be, and that's true. I mean, your whole compressor shouldn't be sweating per se, but if it's just the suction line coming back to it, it's not a big deal. It's hard for me to answer those questions, guys, sometimes because I don't know your circumstances, okay? When someone calls me and says, or messages me and says, hey, my walk-in freezer has ice going up to the compressor, is that bad? It's like, I don't know. Is there good airflow? Is the evaporator coil iced up? And is the evaporator superheat correct? And if they're all correct and there's good airflow and there's no ice on the evaporator coil, then ice going up to the compressor is not a bad thing. It just means that the temperature is below the dew point and the refrigerant line temperature is below freezing. So, but yeah, you do have to know how to interpret certain things. So if you walk up to for instance, a certain thing that happens on a Hoshizaki ice machine is they've had instances where expansion valves can stick due to improper installation practices and whatnot, and you'll get really, really low superheat and it'll flood back to the compressor. So the whole side of the compressor will be ice, and the whole, even the discharge gas coming out the front of the compressor, or the top of the compressor, is not even hot. It's like lukewarm. So yeah, that's low superheat. So, you got to take each situation differently, and it's kind of hard for us to say yes or no, it's completely bad, because we don't know all the circumstances behind it. So, all right. Have I ever used the saddle type piercing valves? You've always been scared to braise on a line with refrigerant in it. The pressure at 15. Yeah. Yeah. I've used the saddle type valves before. They are kind of sketchy, and they are, you got to have some balls to be able to put those in. Jeremy, dude, thank you very much, man. Really appreciate it, man. But yeah, those saddle valves, I've done them once or twice, and I just turn the system off, make sure you're in a safe place. You have everything sanded and cleaned, and you're going to solder really quick. And you want to make sure that you don't get the line so hot that it explodes. Those saddle type valves are a last case scenario. I highly suggest you don't use them unless you absolutely have to. But I can't remember the circumstances as to why I used one, but I know it was a walk-in cooler, and we had to put it on the suction line. And I remember thinking, this is so sketchy. You definitely don't want to do that with any of the hydrocarbon refrigerants, although we pinch off the lines and weld them when we're done. So yeah, that's a whole nother thing. Okay, so William Powers, explain how to properly charge units with expansion valves and or fixed orifice devices. So first things first, the unit has to be working properly. So I'm assuming we're talking about an air conditioning system. The unit has to be working properly. We have to have good airflow. We have to have, my personal preference when I'm charging air conditioning units, especially package units, is all stages are running, not just one stage. I want all stages running if you have 2 stages. And you're going to test your airflow. You're going to get the airflow correct, make sure the coils are cleaned. Once all that's done, then if we're working on a fixed orifice, like a carrier unit with accurator metering devices, we're going to use target superheat. Or on some of the carrier units, if they haven't faded off, there's actually a charging chart, but essentially it's just target superheat. And if we have an expansion valve system, we're going to charge via subcooling. So subcooling being your liquid line temperature difference between the saturated temperature of the the refrigerant inside the condenser, and the difference between those two would be your subcooling. So you basically are going to use a metric as far as like what subcooling you should have. There's some rules of thumb, but I highly suggest you lean on the manufacturer to find out what their recommended subcooling is before you just go in there and assume that you're going to have 10 degrees. Okay, now on a package unit, if you can't find manufacturer's information, it's pretty safe to assume your subcooling should be around 10 degrees, okay? But it also depends on where you're measuring it, okay? I typically like to measure subcooling as close to the outlet of the condenser as possible to get a true liquid line temp. So that's just my personal preference. 716 Appliance Guy, thank you so very much, man. What's my thoughts on pre-charged line sets? You have a big customer here that's all they buy. I really don't care for pre-charged line sets. You know, but I mean, we got to deal with it all the time, but I don't like them, okay? Because you really can't. I mean, I end up cutting them and shortening them because I don't like when people buy a 50-foot pre-charged line set and I only need 25 feet. I don't like leaving coiled line sets up on the roof, okay? So I usually just take them out. And in all honesty, the amount of gas in those pre-charged line sets is so small. So I usually just cut them or recover the gas out of the line set because they usually have ports, right? Recover the gas and then, cut them, follow all proper refrigeration practices because I don't like excess lines on top. I don't like people, when I leave an installation job, I'm always thinking, okay, I want to install this so that way when someone else comes to service it after me, they don't think I'm a hack. So when someone goes up on the roof, they don't understand that the customer bought a really long line set and, you had to coil it up on top of there. They just see it as the person that installed it sucked. So, but yeah, I'm not a fan of the pre-charged line sets. So, but you just got to deal with them sometimes. Is it possible to braise a leak on a capillary tube or will it just clog it? That's a really tough one, Israel Miller. I have done it. What you can do, I'm going to tell you best practices on a capillary tube system. If you have a capillary tube that rubbed out, is to replace the entire cap tube. Okay, that's best practices. But hey, sometimes you got to do what you got to do. So what I will take is a piece of 1/4 inch pipe about 2 inches long, put the cap tube about 3/4 of an inch, maybe, or an inch in on each side of the pipe, the 1/4 inch tube, pinch off the lines and braise it shut. Because trying to braise on a cap tube, you're probably going to plug it up. Now, does that create a flash point? Sure. Okay, you can have a problem there, and that creates that adds more space inside the refrigerant lines, so that could create a problem. But that would get you through a pinch temporarily if you had to replace a broken capillary tube. I've done it before. So, why the sight glass often bubbles at startup? Sterling Archer. So, on startup, your expansion valve is flooding right now, really, really bad. So you have to be very, very careful on startups. We're talking about, let's just say a walk-in cooler, okay? So typically what you want to do is you never want to clear a sight glass when the box temp is really, really high. You want to let the system kind of stabilize out and slowly add gas as you're waiting for the system to come down to temp, okay? You want to be cautious about just blasting that thing full of liquid refrigerant and clearing the glass right in the very beginning because that can become a problem. So oftentimes your expansion valve is just going so crazy right now, and the system essentially is beyond the operating envelope of how it was designed. So you will every once in a while see some bubbles on startup, so you just got to kind of let it calm down and then clear the glass as you get closer to operating temperature, and then also pay attention to your winter charge. If the system happens to have any kind of low ambient controls, such as a head pressure control valve, headmaster, then you're going to add the flood. They call it a flooded charge. After you've seen the box, you have to calculate that flooded charge, and then you have to add that after the fact. So, all right, what brand do I like for walk-ins? I don't know what brand I like for walk-ins. I'm a fan of, I kind of like hodgepodge my walk-ins together. As far as the walk-in shell, I really don't have a preference as long as it's not one of those weird plastic ones or something like that. But as far as the equipment goes, the evaporators, Heatcraft makes a decent evaporator. And then I really, really like the Tecumseh pre-built condensing units. Those are super nice and they're heavy duty and they seem like they're going to last forever. If I have to get a condensing unit with a scroll, then I would probably go with a Heatcraft condensing unit. I'm just not very trustworthy of the Tecumseh scrolls yet because they're still fairly new back on the market. For those of you that don't know, Tecumseh had a major problem with their scrolls about 20 years ago. They came out with a scroll compressor, and it just turned into a disaster, and everybody got rid of the Tecumsehs and went back to Copeland. So Tecumseh came back out with a scroll, but I really don't know how much I trust them yet. So that's just I'm not knocking them. I just don't know. So any preference on a 3-phase monitor, 3-phase protection? David Johnson. No, the only 3-phase protection I've ever used is made by ICM. So I really don't have an honest answer for that one. I've never used anything but the ICM products for my 3-phase protection stuff. So Norlake Walkins. Norlake is, they sell to the customer direct most of the time, just like most manufacturers out there now. So Norlake comes typically with pre-charged line sets. They usually have a Copeland condensing unit with the digital Dixel controller, on there. Nothing bad about them. They're just another builder grade. It's kind of like a builder grade Walkin, so they work, I just don't like the pre-charged line set thing. So, when do you need to use Nylog? There's nothing wrong with that. You can use Nylog basically on any joints that you might have friction, okay, when you're trying to tighten them. So any flares, it's really good to use Nylog to lubricate the surface at which the flare is going to spin. So basically, the old school method was just to use oil on your flares, right? Well, Nylog essentially is oil. It's just a little bit thicker, but it's just oil. So you don't even need to use oil anymore. You just put a little bit of Nylog on the top of the flare nut, basically where it spins on the copper line. And then me personally, I like to put a little bit of Nylog on the threads also, just a little bit, not a lot, and tighten them down. You can use Nylog on gaskets. I'd be very careful about using Nylog on capillary tube systems because they can plug up capillary tubes. I shouldn't say it does plug up cap tubes, but I've always been afraid of Nylog plugging up a cap tube. So I'm sure people will tell me that I shouldn't say that, but that's just my preference. I don't use it on something where it's close to the cap tube, okay? But I will use it like on a pressure control or something. So I'll use Nylog on rotolock valves on the white nylon O-rings. I'll put Nylog on that. So I put Nylog on everything. So it's kind of like Red Hot. You put that shit on everything, right? All right. Let's see. Exactly. Just use it on everything. So exactly. Yep. All right. Let me see. What other questions? Okay, guys, throw some more questions down in the bottom if I didn't answer it, okay? Kyle, can a start capacitor that's not wired to the potential relay trip a circuit breaker? That's a good question. Why wouldn't it be wired to the potential relay? I'm confused on that one, bud. Because the start cap doesn't stay in the system. So how would it not be wired to the potential relay? There's a problem there if it's not. SOE, is MO99 a good retrofit? Hey, bud, I'm not going to comment on that because I've never used MO99. I've heard some rumors about it, but I don't want to bash the refrigerant. I personally, I'm going to tell you right now, dude, I'm not a fan of alternative refrigerants. I like to use, I still use R22 to this day, but again, my buddy Ralph, I don't know if Ralph is in here today. He's always really good in this chat. He works for Honeywell Refrigerants. He's always a really good person to ask questions about refrigerant retrofits. I'm going to post Ralph's email right here. If you guys, anybody has refrigerant questions about which alternative refrigerants to use, I'd highly suggest you email Ralph. So let's see. Why? Okay, I want to get back to this question about the start cap. Did you post a reply in here, Kyle? I want to make sure I get to that question, but I'm kind of confused as to why your start cap wouldn't be wired into your potential relay, because it totally should be. Now, run cap might not be wired into the potential relay, but your start cap definitely should be. Okay, so what device hooks up to the injection port of a Copeland scroll for a walk-in freezer? So typically, that is called a liquid injection valve, okay, or a DTC. David, Tom, Charlie. I wish I knew. Someone had commented that I need to learn my military alphabet. I know there's a name for that, but I just call it the military alphabet. I don't know it, so I always randomly comment with weird letters and stuff like that. So what device hooks up to the injection port? It's a liquid injection valve. And what it does is it takes your liquid refrigerant and it basically, just look at it as an expansion valve, okay? So it basically meters the refrigerant to cool off the head of the compressor. That's all it does. So on a Heatcraft unit, they're using, it's a liquid injection valve, but it basically doesn't get a temperature off of the head of the compressor. So a DTC valve has a sensing bulb like an expansion valve that goes to the head of the compressor. And whenever the head gets so hot, the DTC valve opens up, okay? But there's also a liquid injection valve that basically has a solenoid valve on some of the newer Heatcraft units, and whenever the compressor's running, they turn this solenoid valve on, and it just basically injects liquid refrigerant to the valve, and then the valve meters it off into the top of the head of the compressor just to cool it off. And it's because on a walk-in freezer, you get that low temperatures, you have problems with the compression ratio, and the compressor will tend to overheat. So we need that cooling coming up to the compressor, especially with these new alternative refrigerants that are being used, like R448A. I use R448A as a replacement for R404A. That's the new refrigerant we're using in Southern California, or at least in my stuff of my walk-ins, I'm using 448A. And 448A has a high discharge temperature. So you have to, I mean, it's really important that you have liquid injection, especially on the low temp stuff. So, all right. Oh, this is a good one. So I saw one up here. Did someone ask me about my long sleeve shirts? I swear I saw something in here about that. No, I guess not. I swear I thought I saw something about my long sleeve shirts. I don't know what. There's so many questions coming through, guys. Make sure you just post them again if I missed them, okay? I'm going to get to a couple more of the topics that I want to cover, guys, and then I'll get back to you. Yeah, Whiskey Tango Foxtrot. What the fuck? I was doing a bunch of research about that and wondering, like, what do those things mean in different things? And yeah, Whiskey Tango Foxtrot means what the fuck. Okay, so I'm going to cover some topics in here, guys. Throw questions in caps lock again. I'll try to get to them. All right, let me see what I have. Okay, so I want to talk about the other video that I uploaded where I had a walk-in freezer. And that video, actually, that service call was a couple weeks ago. And I was just sitting on the video footage, and I just decided to edit it down. But so I had a service call on a walk-in freezer, and it wasn't a service call. It was a follow-up. So we had a service call the previous night. I had another tech out there. When he went out there like 11 o'clock at night, the walk-in freezer was completely out of gas, okay, out of refrigerant completely. It was flat. And he found that there was the low pressure control had blown apart, and it blew all the refrigerant out, okay? So he went ahead and replaced the low pressure, or the dual pressure control, I should say. He replaced the dual pressure control, pulled a quick vacuum on the system. And this is another question that I had too, which just kind of ties everything in together. He pulled a vacuum on the system, but he noticed that he wasn't getting a good vacuum. It wasn't holding itself. Basically, he couldn't get down to 500 microns. But he got the system. I'm assuming he pulled it down to like 1,000 microns or close to it, and then basically just charged it up, okay? Because we needed to know where the other leaks were. It was small, whatever it was. He ended up finding out that it was leaking on the accumulator. So where I'm going with this is, sometimes on these systems, when they're flat like that, we don't, especially in the middle of the night, we're going to get them up and running, and they might have other leaks in them. So you're just going to pull the best vacuum that you can, and we're going to go back out and, we'll clean up the system after. So sometimes you got to get systems running. All right. So anyways, he got the system running, but I went back out the next morning just to follow up because he was there super late, and I just wanted to make sure everything was okay. And right when I walked up, the system was not down to temperature. The food was frozen, but the system was not down to temp. Okay. And what I found was I went up onto the roof, put my service gauge. I thought I was scared because I thought maybe it was going to be completely flat again, but it wasn't. It had refrigerant. It was sitting right at 30 PSI on the suction line, and it wouldn't rise any higher. So what I actually found was that the system had a pressure limiting expansion valve's power head. So the valve is not pressure limiting. It's a normal expansion valve. It was probably a 1.5 ton, I'm guessing, 3/8, half inch, whatever, expansion valve. But the power head on the top was a low temp 404A power head, but at the very end of the number stamped on the power head, it said Zebra Paul, as in P as in Paul. And that P means pressure limiting, okay? So what that means is that valve is now going to act as a crankcase pressure regulator or a low pressure regulating valve. So it serves as an expansion valve, but it also won't let the pressure in the system get above the suction pressure above 30 to 35 psi. So what had happened was we had just set the pressure control just a hair too high, and the next morning the unit went into a defrost. So it ran when he left and it brought the box temp down, but it ran until it went into its first defrost, and then it wouldn't turn back on. Okay, so the things that make the system turn back on is we have a thermostat, obviously, that opens a solenoid valve, and it allows the refrigerant from the condenser, which is usually a higher pressure, right, to drive through the system, and then it goes all the way back up to the low pressure control, and then once the pressure rises above the cut-in pressure, it turns the system back on. Well, our system was sitting right at 35 psi. So temporarily what I did was I adjusted the low pressure control down lower, which I'm not a fan of setting those low pressure controls too low, because on scroll compressors, like I mentioned in the video, they tend to equalize the pressures out in the system if the suction side gets too low, especially once they get older. They have like a little port, like a bleed port or something like that in the top of the compressor that equalizes the suction and the discharge out just enough to where, and you'll hear them too, because when they pump off, you hear a pew sound inside the compressor, and it'll you'll see the suction pressure rise back up, and then they'll short cycle on, off, on, off, on, off. So we always we want to set them as high as possible. But in this situation, we had that pressure limiting power head on the expansion valve, so that created a problem. So it's important, you know, when we're doing these troubleshooting, we got to pay attention to that stuff, all right? And it's really easy to think, oh man, this is bad, or jump in there and start solenoid valves bad, all this different stuff. But hey, all it was I went and looked at the valve. I had a hunch, and so I went down and looked at the valve, and sure enough, right on the power head, it said ZP. So that told me it was a pressure limiting valve, and that right at the 30 to 35 range is where it limits the pressure, okay? The next question that I had was, what's the need of a crankcase pressure regulator? Well, on a walk-in freezer especially, okay, if you have a hot pull down, so that means people bring hot products into the box, okay, and there's a heavy load on the compressor when it turns back on. Couple things we do in a walk-in freezer to eliminate heavy loads is, number one, we have a fan delay limit switch, so meaning that the evaporator fan motors won't turn on until the evaporator coil gets below a certain temperature. Okay, we do this for a couple reasons, but one of them is to prevent a heavy load on the compressor, basically. A lot of suction gas going back because the expansion valve is just flooding refrigerant back to it. If we have basically a heavy load or a lot of refrigerant going back to the compressor at once, we can tend to overload the compressor, and it can go off on thermal overload depending on if it's a really old compressor. It could just run high amps. So what we can do in a system that we need that on is we can install a crankcase pressure regulating valve, and essentially it's just kind of like a holdback valve. It basically won't let the suction pressure get above whatever you set it for. And on a crankcase pressure regulating valve, you essentially you adjust it with an Allen wrench until you get it to your set point of where you want it, and then it just stays at that, and it'll never let the pressure get above that set point. When you put on pressure regulating valves, whether it be a pressure limiting expansion valve or a crankcase pressure regulating valve itself, they can increase the pull down times of those walk-ins though. So you want to be cautious about that. Now, on newer equipment, a lot of times if you don't have hot pull downs, you really don't need pressure limiting or crankcase pressure regulators. A lot of times we put those on systems that are designed just to the edge of their operating envelope, basically. So we might put a compressor on there that's just slightly too small, you know, and so we don't want to overload it or something like that. So that's situations where we would need that pressure limiting expansion valve and or a crankcase pressure regulator. So hopefully that answers that one a little bit. Going to get to some of these questions, see if I missed anything here, guys. All right, what else? How does that sound go again? Pew! All right. What is the viscosity of most oils used in refrigeration systems? Joshua, I honestly don't know the answer to that, bud. I don't know if there's a standard viscosity for sure. All right. The only one to go. Let's see what else we got here. All right. Throw some questions back down in the bottom, guys. Okay, there. How do you evacuate lines when installing a Hoshizaki ice machine? How do you evacuate the lines? Well, the Hoshizaki ice machines, the lines are pre-charged, so you don't evacuate them. If you're gonna cut the lines, then you got to put your vacuum pump on there. The lines themselves will have a 1/4-inch port usually or something like that, and you can evacuate them once you braze them together. But as far as a normal Hoshi, if you don't have to cut the lines, you don't evacuate the lines because the whole system's pre-charged. The condenser's pre-charged, the lines are pre-charged, and the compressor is. So you just run the lines, twist them on, use some Nylon, and move on. All right. What is the viscosity? Okay, so I already answered that one. And the fan shut off when the door opens, but turns right on when it's closed. That's right. Yeah. So sometimes we'll use fan switches on our doors too. And some of the newer, like the key to therm evap efficiency controllers on walk-in freezers, a lot of times you can order door switches with those, and they'll help to prevent freeze ups. If you're having equipment where customers are opening and closing doors a lot, or employees are, then it's a good thing to have like door switches on that equipment to help to prevent freeze ups and to reduce the load on the compressors for sure. So, do I have any recommendations on retrofitting an old R12 unit? Yeah, put some 134 in it, man. But I mean, all those different refrigerants, I don't know what the legality of all those refrigerants is right now. Are we still allowed to use 134? I don't know. I don't even know anymore on the new stuff. There's so many new rules. But if I had my choice, I would just put a new condensing unit, new compressor, and or change the oil in it and put 134A in it. It just depends on whether. Yeah, I think you could do that with. Yeah, I'd be careful about putting 134 in a really old compressor. Just changing the oil. You should probably change the whole condensing unit. So, no. Any tips for sizing houses on it for installs? No. Those aren't, you can't use rules of thumb to size air conditioning equipment for houses. It really depends on the climate you're in. You need to do a proper load calculation, and you need to find out what the infiltration rate is of the heat from the outside. There's a lot of factors that go into sizing residential equipment, so you don't want to just ballpark it, because you can go. I mean, some people do, and it gets them by, but you can get yourself into trouble if you're just sizing by the ton of, the square footage of the house or something like that. That can get you in big trouble. All right. Don't the door switches present a risk of flooding the compressor with liquid? Sterling, so if like the key to therm systems, what they do is they shut down the liquid line. It doesn't just shut off the fans. So it just depends. So like if you're working on the little reach-in coolers, yeah, the door switches, they'll just shut off the fans for a few minutes. So the theory is you're not going to have the doors open. I don't know about the supermarket stuff. I don't know if they actually, I doubt that they close liquid line solenoid valves. But on walk-in equipment, if you're going to wire in a door switch, you would usually wire it to the liquid line solenoid valve. So that way when the door opens, it shuts down the solenoid valve. So, all right, let's see what else. How do you start to diagnose a reach-in cooler? So you're going to start from square one. You got to understand the how the unit operates. Don't get in there if you don't understand the sequence of operation. So I'm assuming it's a reach-in cooler. Let's just say it's an older Hvacr reach-in. This really can go to anything, but it's a pump-down system that has a receiver and some solenoid valves and a thermostat. I'm going to check power to the unit. If the unit has power, then I'm going to start at the thermostats. See if the thermostats are calling. If the thermostats are calling, I'm going to check to see if the liquid line solenoid valves are open. If those are open, we're going to put our service gauges on the unit, and we're going to check to see if we have refrigerant pressure. Then our refrigerant pressure should open or should close your low pressure control. And this is just a basic pump down system. Basically when the low pressure gets high enough, your low pressure control closes, your compressor turns on. So, you got to have the right amount of refrigerant. There's a lot of factors that go into that. Now, each manufacturer is different. They have a different control strategy. Some of them don't use solenoid valves. Some of them have, just an expansion valve without even a receiver. So it really depends on the particular reach-in that you're working on. You can feel free to send me an email. I'd be glad to help you a little bit more. hvacrvideos@gmail.com. So, all right, let's see what else. Where to look or how to read the BTU rating of the evap and condenser coil and comp horsepower ratings, especially on walk-in. So that's kind of a loaded question there, Ralph, but let's start with how do you find the BTU rating of the evaporator? So you look at the model number tag on a Heatcraft unit. Let's just say it's I'm drawing a blank here on a model number for a Heatcraft. But the model number is the BTU ratings. The first two digits of the model number of a Heatcraft evaporator coil, like a ADT 146 or something, that's a 14,600 BTU evaporator coil. And then the condensing unit, you're going to need to Google search Copeland and find their website, and you can download the manuals on how to find out what their condensing units deliver as far as BTUs. As far as compressors, same thing. You can open up that Copeland Mobile App that I opened up earlier, and it'll tell you what the BTU rating of that compressor is at what temperatures. All right, I want to kind of, yeah, questions in caps, just like you said. It really helps. So how hard is it to transition from residential to commercial as a tech? It really depends on where you're going, but are you going from residential air conditioning to commercial air conditioning? The biggest thing, like I did a podcast with Zach where he was asking me, and that's on HVAC Shop Talk, and Zach was asking me how I explained to transition from commercial air conditioning to commercial refrigeration. And the biggest thing when you're transitioning from anything is you have to make sure that you understand completely where you're coming from. So if you're coming from residential air conditioning, do you really understand the electrical side? Do you really understand how a capacitor start induction run motor works? Do you really understand the starting components for that compressor? Do you really understand the refrigeration cycle and how the pressures work? Okay. When you step to commercial, it's really not that different. It's just bigger equipment. You're going to start dealing with three-phase equipment, which in my opinion is a little bit easier to work with. You're not always going to deal with three-phase, but a lot of the stuff when you go to commercial is going to be three-phase. And for the most part, unless you're dealing with condenser fan motors, the capacitors, you're not really using that stuff. And the compressors just have three phases of power going to it. So you just need to understand the basics and then have an open mind when you transfer over. I would highly suggest that you get a job with a company that's going to teach you how to transition, and that's not just going to throw you to the wolves. So there you go. I knew there was a question that I saw about long sleeves. So why do you wear long sleeves when it's 95? Because the humidity is so low. Here in Kentucky, it was 95 with 80% humidity today, and my long sleeve was so hot. Yeah, so here in Southern California, I'm more concerned with the sun on my skin, okay, and the heat just from the sun, okay? So if I wear long sleeve shirts, it allows me to stay cooler because we have no humidity here. All right. In the we have monsoonal moisture in the summertime. Usually between July and August, we get like thunderstorms and whatnot. Unless it's raining, our humidity is 50%, and that's insane for us. So we don't have humidity here on a daily. I think that today the humidity is probably 20%, maybe 15%, so we don't have humidity. So when we wear long sleeves, we'll sweat and it'll evaporate really quick. Okay. So long sleeves work really well for us just because it's so dry. All right. Okay. So, next thing, this is a real basic one, guys, but I'm going to go through some basics here. So I'm going to transition over to a display capture again, and I'm going to show you guys, my, hold on, let me pull that chat back up so I can see it, because there's a way that I could do that. There we go. So I'm going to show you guys a really simple thing. I get so many questions about part numbers and links for tools that I used and whatnot, and I tell people all the time, I always put links in my video show notes. Maybe not in my old videos, but in my new videos, I've made it a habit. If I use a tool, there's a link in the video. So this is probably basic for a lot of you guys, but I'm going to explain and show you guys right now. This is YouTube, obviously, okay? So looked up HVACR videos, and I'm going to click on one of my videos right here. If I click on this video, okay, and it's obviously playing a video, but scroll down a little bit right here, guys, right below my video title. There's information about the video. If you click show more, there's all the links to everything that's in my video, all the tools. So in this particular video, I used a DeWalt cordless vacuum, a Samsung tablet. I get so many questions, guys, about where do I get the link for that tool? They're there. Okay. So I try to put them in there for you guys. It's always there. That way you guys can find whatever you need to know. So, all right. So I'm going to transition back from that real quick. A lot of guys put a lot of information in their videos. So other people too, guys, there's lots of great information in the bottom of their videos. There's always show notes there, and you can always find great stuff in there. So I'm going to transition back from this. Hold on. And there we go. Okay, cool. So we're back now. So I'm going to pop up my Word document here. And on R22 replacements, do you weigh in the same amount? What I would suggest on an R22 replacement is to lean on the manufacturer, okay? But typically what you want to do, if I was to any R22 manufacturer, I'd start with about 80% of the charge. So weigh in about 80% of the nameplate charge, And then from that point, I would charge via either superheat or subcooling, depending on whether or not you have a fixed orifice or an expansion valve system. Okay. But typically there usually takes a little bit less refrigerant with the alternative. So start with about 80%. That's a pretty good rule of thumb, and then work your way from there. Always want to be careful when you're using the alternatives though, because is it compatible with the oil? Is it compatible with your expansion valve? Is it compatible with your fixed orifice metering device? So be cautious about that stuff. Adam, you said, will I be at AHR in Florida? You know, I'm really thinking about it, guys. If I can get the time off from work, I'm really thinking about going to AHR in Florida. We'll see. That's something I'd really like to do. I'm definitely going to be at AHR when it's in Vegas, when it comes back here. I think that's not this year, but next year, I think. Yeah, I missed the one in Vegas last time, but I'm only 5 hours from Vegas. I can drive there, no problem. So I'll definitely be at the Vegas one, but I'm thinking about the Florida one. So, all right, let's see. See what I'm missing here. What is that behind me you have wired on the board? So that is a duct detector training board. So a smoke detector training board for RTU units. I made that for my technicians, and then I've used it in a couple of my videos. If you guys go through my YouTube channel and you can search my videos, just look up smoke detector. And there'll be, I think there's 2 or 3 videos where I talked about smoke detectors, and I break them down on that board and how they work with RTU units and how to wire them into the alarm panels and different things like that. So, all right, let's see what else. Okay. Let me see. Seeing if I'm missing anything on here. Did you ever find out who disconnected the compressor on the Linux RTU? No, retread, I didn't. I don't know if it was us. I went through my service history on my invoicing program, and I don't have any history of us disconnecting it. So I don't know if they used another company there. I have no idea who disconnected it, but whatever. I connected it. No harm, no foul. It's working. So Docs. I see that you said guess he doesn't know. I don't know if that was about a question, Docs. If you posted a question that I didn't get to, answer it. Is that for me? I don't know, but let's see. When you wear, yeah, I don't know. All right. Do you trust the recovery tanks you pick up at the wholesalers? Are they labeled as vacuumed? Yeah, they're usually. I have mixed results with the recovery tanks that I've gotten from supply houses. Number one, recovery tanks are dirty, okay? Especially if they're the ones that they clean out. Like my supply house, we swap them. So every time I go in, I basically bring a full recovery tank. FCB 10 skills, thank you very much, man. Every time I bring in a full recovery tank, they give me an extra, an empty one. And if it has plastic on it at my supply house, that means it's vacuumed down. If it doesn't have plastic, that means it's nitrogen charged. I'll usually stick my finger on there and open the valve and just make sure that there's an actual suction. But obviously I see a problem with that. But yeah, you got to be cautious about the recovery things. If I was going to put clean refrigerant in it, I'd probably put a dryer and reuse the refrigerant. I'd probably put a dryer in and a dryer out if I was worried about it. And then probably pull a longer vacuum on it. But most of the time I'm dumping it in the recovery tanks. I'm taking it to the supply house and throwing it away. So most of the time, not all the time though. So, all right, let's see. Okay. I'm going to, hit a couple more things that I have on here. So, okay. So someone had emailed me a question, and they said wherever they were at, they said that they don't have a lot of great trade schools. They don't have a great resource for training. And the company that he works for, and I think he might have said he was like somewhere in the middle of nowhere. And he said that, the company that he's working for doesn't have a lot of training. And he was curious, like he watches my videos and other people's videos, but he was curious about where to get more information about learning the trade. And really, you just got to do some research, just go onto Google and look up the compressor manufacturers and find when they're having training classes, email the compressor manufacturers, the reach-in manufacturers, the air conditioning manufacturers. Go to any training class you can and just get lots of resources. They have pamphlets and papers and whatnot. Take that with you and take it home and read it. We have a plethora of information on the internet now, and we're able to find out just about anything. So, always just research. There's lots of great information on the internet. There's lots of guys making videos on YouTube now. Just be cautious. I'm not saying that I know everything, okay? But I'm just saying be cautious, you guys. There's some people that have information that's not correct. So just be cautious. You can usually tell. You can look at the comments and you can see like if they have a lot of support in their comments, usually probably means that they're doing pretty good. So, all right, let's see what else here. Is a humming compressor going bad? It's hard to say, Justin. There's so many factors about a humming compressor, dude. There's so many factors. You need to check, amp draw going in. You need to check the superheat coming back to the compressor, the pressures, make sure it has the right compression ratio. There's so many different things. So, how to determine if a reversing valve works on O or B for the thermostat? I don't know if I understand your question there, bud. Human rights revolution. So, are you asking me how to determine if a package unit has a fail in heat or a fail in cool reversing valve? So that means that if the reversing valve's not energized, if it's going to be in heat or cool. I honestly don't know how to tell you that. As far as most thermostats, at least most of the thermostats that I work with, you can set it up to be fail in heat or fail in cool for the thermostat. So I don't know if I'm answering or confusing you even more there, but all right, let's see. You have a compressor that is chirping like a bird. It stops when you barely tap it, but it's running at 25 degrees on its lowest thermostat setting. Any thoughts? That's a hard one, bud. That's such a loaded question. I don't know, man. Feel free. I think that's a little bit too technical, for me to troubleshoot in a live stream like this. So feel free to send me an email, bud, to hvacrvideos@gmail.com. HVACR. Oh, that's wrong. I'll type that in the chat real quick. At gmail.com. Feel free to send me an email and I'll try to answer it. We can find out some more information on there for it. Yeah, there's so many questions. Is it pumping down and holding? I mean, there's so many different things. So everybody's trolling for talent right now, Adam. Good gosh, man. Driving me nuts, man. Johnstone University, Danfoss. Many more online sites have great educational resources. Definitely check out HVACR School too. Probably one of the best resources out there. HVACRschool.com. And that is Brian Orr's website. Lots of great information. He does podcasts. He does daily tech tips. Lots of great resources on HVACR School. So highly suggest you guys check that out. Let's see. Have I ever used an air curtain for a walk-in door opening? No, I've never used an air curtain. I've used plastic strip curtains, but never an actual air curtain. No, I've seen them done, but I've never used one. So I feel them when they have those really fancy ones like at Costco and whatnot when you're walking in their big giant milk coolers and whatever, but no, I've never used one myself. So you can't figure out how to differentiate a failed reversing valve or a failed TXV. That's a hard one, Sterling. Again, kind of need to know a little bit more about what's going on. But a failed reversing valve, I would imagine you should be able to do temperature checks to be able to feel if it's failed. Maybe it's stuck halfway in the middle, or maybe it's sticking. That could be a little more difficult. But yeah, I'd be glad to talk more over email if you want, Sterling. So yeah, True Tech Tools also has free education too. So lots of great resources out there, guys. A lot of guys in here have YouTube videos too. There's a lot of cool channels. So definitely check that out. Okay, so do I think social media is helping put a different view on the trade workers? I think social media is kind of helping, but also at the same time, you got to be careful some of the groups you get in. I'm part of all the different groups on Facebook, but some groups aren't really educational and they're more or less just places for people to blow off steam. So be careful about asking educational questions in those groups. Okay. And there's nothing wrong with those groups. There's groups that are there to mess around in. Okay. If you want to go on social media, the HVAC School Facebook group is a really, really good group. And Brian Orr and all of his admins, they tend to keep that group in check, meaning that they try to keep it as educational as possible. So if you're just looking for education and help, the HVAC School Facebook group is a really good one. As far as other social media, yeah, I think social media is giving a good perspective on the trading outlook, being able to see people talking about things and, I think it's all good, but I also think it can hurt people too with the way that people go on social media and then just bash like, oh my God, this sucks so much. And I hate working in this and I hate working in that. Hey, if you hate your job, you need to move on and move to something different. I mean, I don't see the point in bitching about things so much, because if I'm going to bitch about my working environment every single day, then, posting it on social media is not going to help me. Obviously I need to make a change in my life if I'm that miserable. So, but whatever, I'm not judging people. So, yeah, no worries, bud, for following you on Instagram. How could you tell if someone has installed the wrong nozzle for the evaporator? R22404 nozzles can cause a long diagnosis process. Yeah, that's an interesting one. So I'm going to be honest with you. Most of the time, going from like R22 to 404, you might see some peculiar icing up issues. That's a hard one. You can usually, if you're curious if someone's installed the right nozzle, it's kind of a pain in the butt to pull them off. I really wish nozzles were removable per se, especially when we were using flare valves. It was probably a lot easier, but flare valves are just a problematic in their own for expansion valves. But yeah, that's a hard one on how to diagnose a nozzle. I know Sporlan has some great literature on it on their website. If you just look up Sporlan expansion valve nozzle in Google, it'll come up, and they have some great resources on how to diagnose that stuff. But I know you're going to see some icing up issues for sure. My Google was just talking to me. Huh, that's weird. I thought I turned my volume off. Apparently Google's volume's not off. That's weird. Yeah, my volumes are all down. Oh, my media wasn't down. That's why. Huh. All right. Let's see what else I got in here. Okay, what else? Any tips on troubleshooting Headmaster flooded condenser controls? Yeah, I mean, I work with Headmasters quite often. Headmasters are fairly easy. Usually, for the most part, Headmasters will stick open or stick closed. Occasionally, they'll bleed by slowly. So, I mean, obviously, making sure you have the right refrigerant charge is the biggest thing. You need to fill that up with the proper flooded charge. If you don't know the flooded charge, you can always put the maximum charge in the system. Obviously, the maximum charge is going to be the system filled up to 80%, basically, because you never want to overfill your receiver, because that can lead to some catastrophic failures. Send me an email. I could talk to you a little bit more about it. I don't really find Headmasters to be too complex. They're pretty simple in nature. So, but yeah, send me an email. We can talk about it more. So hvacrvideos@gmail.com. So, let's see. Have you ever worked? Yeah, Google is always listening for sure. I got Google things all over my house. So have I ever worked on ultra low temp freezers? Yeah, I have. Most of the time, I've never had to put my gauges on ultra low temps. I've never had to change the special refrigerant blends that they have in there. It's always been control problems with the low temp stuff, the ultra lows. I don't do any hospital work anymore. I did in the past. And yeah, we would work on some of those weird ultra lows that they'd keep vaccines in and different things like that. So, hey, thanks so much there, Llama Fat Kid 1. That's an interesting name there, bud. No, so Chris, 180 people are spending their Monday night watching me. Is there 180 people in here? That's crazy, guys. That is kind of crazy. Every time you have a Headmaster, you think you're your ex-wife. That's funny, dude. What's the best way to determine if a TXV has failed, specifically in residential? Putting your gauges on the system, making sure you have the proper airflow, and then you're going to look at the superheat and the subcooling, and that's going to help you to determine whether or not you have a bad expansion valve. If you're really, really unsure, you can check the refrigerant flow. If you're really lucky, then the power head failed on the valve and the valve just slammed shut and it won't let refrigerant through. But if you're trying to diagnose a sticking valve or something like that, you're going to pay attention to your superheat and subcooling. And that's going to help you to diagnose whether or not you have a bad valve. There's a lot more information there, but I don't want to go too far into depth in this. I know that Brian Orr has some good podcasts on that and videos probably too, to be honest with you, on HVAC School. So, all right. So I got some more stuff on my thing right here that I want to talk about. So another person had asked me about my video with the expansion valve that had a pressure limiting power head on it. And they were curious what the purpose of the pressure limiting power head. And specifically, they asked if it prevented slugging. And no, a pressure limiting power head nor a crankcase pressure regulating valve is not going to prevent slugging. What it does is it just reduces the suction pressure, but it's not keeping liquid refrigerant from going back to the compressor. The only thing that can really keep liquid refrigerant to a certain extent from going back to the compressor would be a suction line accumulator, okay? So the pressure limiting power head does not prevent slugging. It's just there to hold back the refrigerant flow to make sure that the suction pressure doesn't go above about 30 to 35 PSI on the 404 systems. It could change for each one. Do I ever work on supermarket rack systems? No, I don't, bud. Sorry. You got a walk-in cooler callback with a frozen expansion valve. Charge is good. Filter dryer is good. Subcoolant is good. Suction is really low, and bulb is clamped and insulated. Any thoughts? William Hunt. There's a lot of things that could be there, bud. But your expansion valve could have moisture in it. Now you say frozen expansion valve. Is the rest of the system frozen, or is it just the expansion valve? So Jeremy, thank you so very much, man. Oh, you're not trolling for talent. Dallas, thank you so very much, man. I really appreciate it. No, it's all good, Jeremy. Let's see. I lost my train of thought there. Okay, so I'm talking about that expansion valve. So walk-in cooler callback, frozen expansion valve, charge is good, filter dryer is good, subcooling's good, suction is really low, and bulb is clamped and insulated. Any thoughts? First off, is it the right expansion valve? Does it have the right size on it? What's the refrigerant? You really need to talk a little bit more in email, but I'm just kind of throwing out the quick topics. Next thing is there a strainer on the valve? Is there a removable strainer, and is the strainer dirty? Oftentimes that can happen. There could be a strainer there, and that strainer could be plugged up. You might be able to just pull the strainer, pump the system down, pull the strainer, check it to make sure it's clear. Unless there's something stuck inside the valve, you can probably get away with changing the power head on the valve if you're worried about the valve being bad. Put a new power head on there, make sure it's clamped where it's supposed to be, and move on. Majority of the time, I'd say in refrigeration, majority of our problems. Ted, thank you very much, man. Awesome, guys. You guys are so cool right now. This is really cool. I'm sorry, lost my train of thought. But yeah, a lot of times on refrigeration systems, the expansion valves, they're just the power heads usually fail. That's like the weakest point on an expansion valve. Unless there's something stuck inside the valve, like it's gummed up with gunk or something like that. Majority of the time, the spring and the seat and different things in the expansion valve, they typically don't go bad. So, a lot of times you can get away with just cleaning the strainer and or changing the power head on the expansion valve. So, guys, awesome, man. Thank you so very much for these super chats. That's really cool. So, let's see. All right. I'm looking at my my list of things here. Guys, there's so much misinformation about the R22 ban. Okay. I've had so many comments about my videos lately about topping off the systems that have R22 in them. Guys, as of right now, and unless something changed that I don't know about, and I don't think it has, as of right now, we're still allowed to top off R22 systems. Okay. The customer, and we don't have to fix the leaks unless the leak rate is a certain percentage and the system has more than 50 pounds of refrigerant in it. Right now, the EPA, the law states that systems that contain more than 50%, the leaks have to be repaired if the leak rate is X number of leaks per year or whatever. Okay. So, but on our residential and our small light commercial stuff, we can still top off our R22 stuff. Okay. Until they change the laws, it's not illegal to top things off. I was just looking at the EPA website myself, and it says it right there on the website. 50 pounds or more, you have to fix leaks, but below 50 pounds, you're good to go. Now, we have a moral obligation to try to fix leaks for sure, okay? And I'm always recommending to my customers. I'm not one to go out and just gas up and move on. That's not my style, okay? But I do show in my videos, like I'll get the customer going, put refrigerant in there, and then quote the repairs, and then we go back and fix them. There's nothing wrong with that. That's totally legal. So a lot of people think that R22 is going to be illegal as of 2020. No, R22 is illegal to manufacture in the United States and to import into the United States as of 2020. But our manufacturers have stockpiled millions upon millions of pounds of R22 to be used for the foreseeable future. So, Adam, dude, thanks, man. Really appreciate it, man. You guys are awesome. So, all right. Yeah, exactly. We just can't make it anymore in 2020. So we can still use it. Now, yes, it's in our best interest to urge our customers to change over away from these R22 and these 404 systems for sure. Okay. A 404 is a little bit different, especially in California, because they're approaching that ban a little bit different. So in California, 404, and this will become federal for you guys as of 2020. But for 2019, we're not allowed to use 404 on new installations anymore. We're still allowed to fix systems, but if we change any major components, we have to change the refrigerant over, and we're not allowed to use 404 anymore. But that it's kind of weird how they approach that band. I'm sure it's because there's less equipment out there with 404 than there is R22. So, Ted, dude, you guys are getting in a bidding war or what? Thank you guys very much, man. And guys, Dallas is the man in here. Okay. Or, I'm sorry, Dallas, you are the man, but, I'm sorry. Ralph is Dallas fan. That's why I said that. Again, Ralph is, got lots of great information. Feel free to email him. Why the heck did I lose his email address? I already put it in here once before and I seem to have lost it. I will put it right back in right now. Hold on just 1 second and I will get Ralph's email address. He's the man to talk about refrigerant regulations. He works for Honeywell and he's always willing to answer your guys' questions. So I'm going to copy his address right now and I will paste it in the chat one more time for you guys that are in here now. Okay, so here's Ralph's email address. Feel free to email him. He will be glad to answer your guys' questions. What the heck, man? You guys are going crazy with these super chats. Thank you so very much. All right, so $3.90 a jug of R22. Yeah, I want to say it's in the 400 range here in Southern California, but I'm not going to discuss exact prices. So, all right. Yeah, no worries, Ralph. Thanks for always being there. Ralph's always willing to answer questions in here. Okay, so I'm going to go back to my sheet right here real quick and answer some more of these things that I have on here. Jiminy Christmas, guys. Nathan, thank you very much, man. I really appreciate it, dude. Okay. Let me see. What else I got on here? Copeland Mobile Walkthrough. I already did that. Jiminy Christmas, guys. Thank you. All right, so discuss Linux. How to convert low temp. Oh, this is another really good one, guys. So I had a question that came through a couple weeks ago about how to convert a system from low temp to medium temp. So the person emailed me and said, hey, I got a customer and I don't think they did a lot of commercial refrigeration work and they had a walk-in freezer and the customer wanted to convert it to a walk-in cooler. So a lot of people think the easiest way is just turn the thermostat up, but that is not the case. So we're going from a walk-in freezer to a walk-in cooler. Jeremy Goldsworthy, dude, thank you very much, man. I really appreciate it. So on the walk-in freezer to walk-in cooler, a walk-in freezer is going to have defrost heaters. So essentially you're going to have to strip the defrost portion out of the coil. More than likely, if you want it to work right, you're going to have to make it air defrost if you want to convert the coil over. A lot of times, Adam, dude, you guys are going nuts, man. What do you guys... Thank you very much, man. This is, I don't know what to say. You guys are freaking, I appreciate that you're having a bidding war on my page right now. So, yeah, Dallas, anybody that's interested in Dallas, send Ralph. I'm getting distracted here. Send Ralph that email. Guys, you guys are blowing me up with these super chats right now. What the heck, man? I'm getting distracted. I don't even know what to say. So as far as the walk-in freezer goes, okay, so we're converting it to a walk-in cooler. The other things we have to pay attention to with the walk-in cooler is that compressor is not rated necessarily, depending on how old it is, to have the warmer suction gas coming back. So remember, our compressors are typically suction gas cooled. So the refrigerant coming back to the compressor is, good gosh, guys. So the refrigerant coming back to the compressor is cooling off the windings of the compressor, okay? So if we have a low temp compressor and we just turn the temperature up and convert it to a medium temperature, you can possibly overload that compressor or overheat the compressor, okay? So you got to be careful about that. That compressor may not be compatible with, holy moly, Javier, dude, thank you guys. Good God. You guys are nuts right now, man. I really appreciate this. So I totally don't even know. Thank you. So, yeah, you got to be so careful about the compressors, okay? If that compressor is not rated to have that warm suction gas coming back, then the proper way on that system would be to change the compressor, okay? Adjust the low pressure control settings and take the heating elements out of the evaporator coil and convert the evaporator to air defrost, okay? Best case scenario, you change the evaporator and the condenser, okay? But you can get away with leaving the same evaporator, pulling out the defrost components, and changing the compressor, okay? But you want to be cautious about that. Now, I've done walk-in freezers to walk-in cooler retrofits where the customer was fully aware and they didn't want to do any of that stuff. We just pulled out the heating components and we left the same compressor. It worked, but you just have to understand that there's a potential for there to be problems. So, Telecom, dude, thank you guys. Good gosh. What am I doing here, man? I don't even know what to say. There we go. Right on. Yeah, I'll see what I can do about AHR. Good grief, guys. I don't even know what to say. I'm blown away, man. You guys are awesome. So, yeah, we'll see. I'll try to make it to AHR. I promise. Okay. So, all right. Throw me some more things in here to talk about, guys, because I'm running out on my sheet right here. So, give me some more questions in here. See what I need to go. Yeah, I'll see what I try to do. Yeah. I'm not even gonna comment. That's awesome, guys. Thank you so very much, man. I really appreciate it. All right, so put some more questions in here. That way I can answer them for you guys. Okay. Let me know what you guys got. If there's any questions that I missed or anything that I didn't answer, let me know. All right. Let me see. Ted. Good grief. Adam. Good gosh, guys. I don't even know what to say. You guys are blowing my mind right now. Good grief, man. You guys are all the man. Good gosh. I don't even know what to say, guys. You guys are awesome, man. Really, really appreciate it. So yeah, throw some more questions in here, guys. Let me get to some more of these things you guys have. Have I ever worked on a U-line refrigerator? Paul, no, I haven't, man. I really haven't worked on a U-line. Wait, yes. Yeah, U-line makes those tiny little, don't they make the little like throwaway refrigerators? Those itty bitty little things? I think I have worked on those before. If that's what I'm thinking of. They make the little, you know, thing you throw in your room or something like that, don't they? I think I've worked on them in some of the yeah, there you go. More Honeywell refrigerant. Yeah, I'll do that, Ralph. Yeah, but I think I've worked on the U-line stuff before. I remember working on them when I was working in the hospital stuff. So, what's the worst thing I've seen on call? There's been a lot of things. Some of the scariest things that I've seen was I used to be so intimidated by motor starters for exhaust fans, like 480 volt. They used to scare the crap out of me, but that's not really scary to most people. But just the old furnace, actual magnetic motor starters, those things used to just scare the crap out of me when I'd see them because they would hum and I would always think they were going to electrocute me. As far as the worst thing that I've seen, okay, I'll tell you. The worst thing that I've seen was when I was working in a hospital morgue one time. The morgue didn't bother me. I'd seen bodies. Bodies were always in body bags, so you never really saw the actual body. But I mean, sometimes the body bags would be ripped or whatever, and you could see. But that never bothered me. But the worst thing that I saw was when I opened up a 4-passenger. Good gosh, Ted. Thank you very much, guys. I don't know what to say. You guys are blowing my mind right now. So when I opened up a 4-passenger morgue cooler one time, and there was a baby body bag. Like it was a tiny body bag. That was, for me, that was the worst. That one hit me so hard. When I opened that up, I didn't see the actual baby, but you could tell it was a baby inside of it. And that one hurt so bad. Just to see that body bag. Ted, good grief, guys. This is nuts. I don't even know what to say. I'm just blown away, man. Just blown away by you guys right now. I don't even know what to say. So, yeah, that was the worst thing, was the tiny body bag. So, if I'm missing a question, I see Chad. Where's Chad at? Someone put a question that wasn't caps. Simple question here. Compressor at work is reading pressure too high. It has an error code. That's an interesting one, Juan, because I don't know the answer. I'd really need to know what is going on there. We'd need some more information. So send me an email, Juan. I would be glad to help you out. So, yeah, people are going crazy with the button. You guys are nuts, man. So, if you're on for 20 minutes, it will be used. The prepaid things ran out. Oh, yeah. All right. Do you guys start having CO2 as refrigerant? It's the new big thing over there. No, Sterling. I mean, there's some, yeah, the supermarket stuff for sure. They're using CO2. I don't deal with anything. I've seen some of the bottle coolers in the gas stations by like our soda distributors. They like give them bottle coolers, and I've seen some of them that have CO2 as the refrigerant, but I've yet to work on a CO2 system. There's a lot of the supermarket guys that I've talked to, and it's really interesting with what they've told me about the CO2 systems. I'm intrigued. I'd love to go put my hands on one just to see one and film it or something like that one time. So that'd be kind of cool just to go tour them. But no, I've never worked on a CO2 system myself. So, all right. Almost 200 people. Good grief, man. Am I a fan of the Corel Easy controllers? Keep on trucking. Dude, I got to say, I don't want to talk crap about people, but I'm really not a fan of the Corel controllers. And it's just, I see them on a lot of Silver King refrigerators, and they're just, I don't know, they're kind of a pain in the butt to me. But I know a lot of people like the Corel stuff, so I prefer like the Dixel stuff. I like the Dixel controllers, and it's probably just because I'm used to the Dixel controllers and I'm comfortable with them. But I just don't know about the Corel too much. I haven't had good luck with them. So, Adam, you guys are nuts right now, man. I don't know what to say. I don't even know, guys. I don't even know at this point. I don't even know how I see what the donation window is right now. So I just see they pop up and then they disappear. So I don't even know what it's at right now. I'm not super smart when it comes to how to figure out all this stuff. This is nuts though, you guys. I don't even know what to say. So, Ted, good God, guys. I don't even know what to say. You guys are nuts, man. You guys don't need to keep doing this, man. I mean, I really appreciate it, but good grief. You guys. All right. So would I expand my work base or what I'm comfortable for my viewers? Chillers, freeze. You know, the hard problem, it's Diehard01. The problem with expanding what I work on is I don't have the employees that have the capability of working on that stuff. So, and that's something as a, dealing with the business side of things is, and I mentioned that on Zach's podcast, is I'm limited by my employees. And I'm not talking crap on my employees. I have really good guys that work for me. They're the nicest guys ever, right? They're cool. They know what they're doing, but they're not capable of working on that stuff. And I'm afraid to go hire someone that knows how to work on something and me not know how to work on it yet. Okay. Because I'm kind of a control freak. So it's kind of hard for me to just expand my work base and hire people. It's really hard to find people in general, but I would have to be comfortable working on something before I would just hire people and start doing it. So, I'm always intrigued to work on new stuff. And I've mentioned it, I think even on Zach's podcast that I did, I used to do hospital work, and the customer parted ways with my company about 2 years ago or something like that. And we just went our own ways, but, it was fun and I liked it. And it was a challenge working on the scientific refrigerators and stuff, but it was difficult though too, because I had to be on call 24/7 because my guys weren't capable of working on a lot of that stuff. So I was limited by my employees. And that's what I mean by that. Nothing wrong with my employees. They're just not guys that work on that stuff. So when recovering refrigerant, what's the highest pressure temp that's safe going to the cylinder? Well, it depends on your recovery machine. So I use the Appion G5 Twin, and I think it has a high pressure control in it of like 450 PSI or something like that. So, there's a lot of things you can do to keep that pressure down though. So if you guys see when I do my recovery process, I take my tank, and if it's really, really hot, if I'm working in like 120 degree conditions, right? Because that refrigerant is going to be a lot hotter than that. So I will put the refrigerant cylinder in ice, all right? And then I will also fill it with a little bit of water so that way it has some method of heat transfer, because ice itself isn't really going to work too well. You got to have some water in there. And it's obviously going to melt the ice really fast. You can always put a hose in there and let it keep running. But then I'm going to use bigger diameter hoses, 3/8 inch hoses, remove the Schrader cores out of everything, remove your core depressors out of your hoses. And all of that's really, really going to help. I have one of those subcoolers, molecular transformator by CPS, I believe, but it's essentially just a subcooler. I have one of those, but I found that those are kind of restrictive for me too. So I find just putting my tank upside down in ice water, letting the water flow through it, and using the 3/8 inch hoses moves my recovery process along. So, all right. Yeah, exactly. Okay. Best book in HVACR, Israel Miller. It's, commercial refrigeration for air conditioning technicians. I got to get a hold of Dick Wurz and tell him to send me a book for free, because I've sold so many of his books, but I'm joking, because Dick Wurz is a really, really nice guy. I've spoken to him, one time actually, but he's a really cool guy, and I've taken a class with him. But he wrote a really good book that basically covers the transition from commercial air conditioning to refrigeration. And in my opinion, it's one of the best HVAC books out there. I really, really like that book. In the show notes of this video right now will be a link to his book. It's a great, great resource for information about learning about refrigeration and air conditioning. So, yeah, you guys are all nuts, man. All right. All right, guys, it all depends on the cylinder. Yeah, it depends on the cylinder too. That's true. So, always want to fill it to 80%. That's right. Okay. Appion opens up at 550 PSI. There you go, bud. Thank you. I knew there was a pressure control in there. So, Adam, I don't want your wives to get mad at you guys. So, all right. So what is the most common parts that wear out on scroll compressors. So a lot of times on the scroll compressors, what can wear out is, I'm trying to think here. On the scroll compressors, what's the most common part? So what I see here in Southern California, one of the most common parts that wears on a scroll compressor is the pressure relief valve inside the compressor. So we're in the Inland Empire and we have warmer summers out here. So last summer we hit an extreme high of 120 degrees. That was only for one day. Our typical summer is about 110, 112 degrees. Well, when you have that, and we're using 404A refrigerant for most of our walk-ins and medium temp refrigeration. So we tend to run higher pressures. So on any given day, our discharge pressure in our system is going to be about 450 PSI in the middle of the summer. Well, inside that scroll compressor, as it gets older, especially on the low temp models, when, like, let's say you have a dirty condenser or a bad condenser fan motor, your compressor can go off on internal overload. Okay, so it has an internal electrical protection inside that if the motor windings ever get too hot, it'll thermally disconnect itself from the electricity coming in. And also, you also have a valve inside the compressor that'll essentially separate the scroll if the pressures get too high. And if that happens too many times, I've found that whatever that mechanism inside the compressor can fail, and the compressors can go off on internal bypass too often, even when it's not that hot outside. And I think I have talked to the Copeland rep in my area too before about that, and he has said that, yeah, if it happens too many times where the scroll set inside the compressor bypasses, and the way you would know is you would go up and it would feel like the compressor's running, but it wouldn't be pumping. You wouldn't have any compression ratio, but you'd have proper voltage and you'd have about half the amps. So the motor inside's running, but the scroll set has disconnected. And it's like an internal pressure relief. And if that happens too many times, it'll happen prematurely. It'll start becoming really weak. So in my opinion, that's probably the most common thing to fail in the scroll compressors in our area. Other than that, the scrolls are pretty bulletproof. They can take liquid refrigerant like a champ, in my opinion. So what's the best kind of AC compressor? That's a hard question, man. I mean, I'm a fan of the Copeland scroll compressors, but I don't know. That's kind of a loaded question. You'd have to send me an email and we can talk more about it. So for many years, you've worked on commercial reach-ins, walk-in coolers, freezers, ice machines, margarita machines, Las Vegas, made a great living doing so, and you love the work. Yeah, I mean, I love doing this. I don't work on margarita machines, but I love doing reach-ins in restaurants and stuff like that. It's fun. Sometimes they can be kind of nasty. The boxes can get kind of dirty, but yeah. It feels pretty cool to be liked, Israel. That's pretty cool. So what are my thoughts on York or JCI? I don't have anything negative to say. I mean, I'm not a fan of York package units like the Predator units. They're kind of like a cluster F to work on. That's just my opinion because I'm not comfortable with them. But I have no opinions on the company in general. I know lots of people that do great working for them. Most of, I think, if not all, JCI, I don't know if all of it is, but they're mostly union. And if that's strong in your area, then consider. I don't know what that question was if you like that. So will you be able to buy merch from France? Sterling, I'm trying to figure that out, man, because I know I have people that want to get the merch to I know you in France, and there's someone in Australia, and there's a few people. So I'm going to do some research and try to figure that out. So, yeah, exactly. So do I do blast chillers? Yeah, Ralph, I've worked on them before. Blast chillers essentially are just, they have an oversized condenser unit and oversized evaporators. That's essentially what they are. And they just are capable of pulling that system down to temp so flipping fast, it's ridiculous. But yeah, I have worked on them before. So, all right. They had to be approved. Now it's going nuts. I was wondering why he had no reaction before. Yeah, that was nuts, guys. It's just freaking crazy. So, pull up a chair. So, all right. You have stuff negative to say, pull up a chair. What do you mean by that, Adam? I don't know. All right. Mostly Copelands are black. Red is no more. All right. Let's see. What are my thoughts on York JCI? All right, gentlemen. We're probably going to wrap this up because we're going on an hour and a half, unless you guys have more questions you want to put in here. Yeah, throw some more questions in here. So you have 13 years of installs and an owner who is existing because of it. Thanks to Ted, we are doing train now. Right on, Jeremy. That's good, man. That's good. So predict the next 5 years. if I can make some stickers. I'll see what I can do, Sterling. I'll see what I can do about the stickers. So let's see if my logo turns out good. I'm getting my samples for my t-shirts tomorrow. So I actually ordered them from a legit company. I'm not trying to do Teespring anymore. So let's see how the samples turn out. And I have really good confidence, and I'll have hats and shirts. So let's see. And then maybe if the logo turns out good, maybe we'll do stickers too. So how do you go about training my guys, ride along classes, etc.? So like I have an apprentice that's working with me right now. If I hire an experienced person, then they're going to go directly into the field. They might ride along with me for a couple days or something like that, but then they're going to go into the field for the experienced guys. But my apprentice is going to ride with me for, it just depends. But I mean, I plan on him being with me for at least 6 months, if not longer. It just depends on how fast. And I wouldn't just throw him out to service right away. Let's say that I feel comfortable after 6 months and I can slowly put him in a van, and then he can still shadow me on calls. And then sometimes I might be able to let him go out to a service call a half an hour before me, get started on things, and do that. That's my preferred method of training someone is just to slowly break them into the field. So the apprentice that's riding with me right now, like I don't necessarily make him do everything, right? I might just have him constantly put service gauges and the smart probes on the units. Like today we were doing package units and I had him putting the smart probes on. He's watched me do it a bunch of times. So now I'm going to let him do it, and he's going to access the system, and he's going to tell me what the pressures look like before I look at the tablet, you know, and it gives me my readouts using Measure Quick. And, you know, I just slowly let him do little things at a time and let him watch me for a long time. And then that way, you know, he can slowly get into it. I don't plan on throwing him out there and saying, hey, go do a service call. No, that's not my style. So, all right. What's going on? What's going on about next year's R22 ban? Okay. So, Neva 32. What I would highly suggest is that you reach out to Ralph at Honeywell. And let me pull up his email right here. He will be able to enlighten you a little bit more on the R22 ban. R22 is not being banned. Okay. What it means is that R22 will be, you are not allowed to manufacture it in the United States, and or you're not allowed to import it into the United States. But everything that's already existing and everything that's already recovered and reclaimed and cleaned up can still be used. So we're still going to be allowed to be using R22. It's just the price is going to go up a little bit, and we're not allowed to import it into the United States anymore. Okay, but we have millions upon millions of pounds in stockpiles in all of our distributors that are still going to be around for many years to come. So yeah, guys, hit the like button. I'd really appreciate it. So, okay. So can I explain Radziok? I mentioned it already in the beginning of this, but I'll let you know right now. So, the approach temperature is really just an ass backwards way of looking at subcooling. Okay. So the actual approach temperature, what you do is you take outdoor ambient temperature, and your actual approach temperature is the difference between the ambient air temperature and the liquid line surface temperature leaving the condenser. That's all it is, okay? Now, the definition of subcooling is going to be the difference between the liquid saturation temperature, all right, and the liquid line temperature, all right? So approach temperature is really just a way of verifying the performance of the condenser, looking at the ambient air coming into the condenser and the liquid line temperature leaving the condenser. That's all that it is, okay? And that's typically used on Linux units. They use approach temperature as a charging metric, okay? So when a compressor goes off on internal bypass, is there a way to better cool it down before using a hose to get the windings to close? So I made a video, Scott, about this little tool that just came out, and it's called a Cool Presser. Cool Presser. I'm going to pull up a link right now. There's really no better way than to cool the compressor, okay? That's the best way, is cool it off. But I'm going to pull up this little tool right here, and it's a really cool little tool, and it's a hose bib, and it's magnetic. Let me pull this up real quick, if I can pull this link. Okay, so biotech.com, Control-C. I'm going to put this in here right now. Go check this out. Click on their website, go to that website, and look at this little tool. It's a magnetic device that you hook the hose up to. It has a ball valve on it, and it's magnetically attached to the top of the compressor, and you're allowed to cool the compressor off. And you can do it, and it cools it off super fast. But other than that, no, just using a hose to cool a compressor, that's my preferred method. So, all right, close live chat for a moment to CV look like for the video. Consider your contribution in lieu of super chat donations. CV look like for the video. I don't know what that means, David Johnson. So HVAC Mexico, send me an email. I'll connect you with our reps in Mexico. Yeah, definitely. Okay. Have I ever worked on an Addison DHU unit? No, I haven't. Sorry, bud. Frost HU. Yeah, I have not. So, all right, gentlemen. I am going to wrap this up, guys, because we're going on an hour and a half. So send me questions to hvacrvideos at gmail.com. I would be glad to answer them for you guys. I'm going to put this in here. gmail.com. Okay. Send me any questions you guys have. I'll be glad to answer them. Really appreciate it. Yeah, that's pretty much it, guys. So I'm going to go ahead and wrap this up. I'm going to close my intro picture over, and I'm going to fade in the outro music right now. Here we go.